total time is, I don't know. So let it be T1 plus T2. T1 for the time from this part to this one, home to school, T2 for the time from school to home. So T1 would be, what is T? Let's revise the formula. What is speed? Distance over time. So what is time? Distance over speed. So T1 would be, in that case, T1 is the time distance from home to school, and time, not time, the speed from home to school. So this is x upon 20. Did you get this point? We had to find total distance over total time. Total distance is the distance which he covered, that is from here to here and back from here to here, that is x plus x. This is giving me 2x. This is clear. Total time, let us say that it has taken time t1 while going here, right, in this direction. So T1 is what? Time is distance upon speed. What is the distance it is covering going in this direction? This is x, and by what speed it is going? 20. So x upon 20. Simple. So that is why x upon 20. While coming back, we have taken the time to be t2, which would be equal to the distance it has to cover, that is x upon the speed with which it is covering the distance. So 5. So x over 5. Now how do we do it is, I am taking x common out, I am left with, so this x gets cancelled out and all you are left is with only numbers. So ultimately your answer will be in numbers. So this is how you calculate average speed. Alright. Okay, let's do one more question. I would request you to listen my question and try to make a diagram for it. Making some sort of rough sketches, the diagram, or I'll be calling it FBD, that is free body diagrams. Making FBD or free body diagrams is very important in physics, especially to understand the concept what exactly is happening. It gives you a mental picturization of what is going to happen, and you get the concept practically, and it becomes actually easier for you to understand and do the question. Now I want you to understand my question and try to solve it, but first of all I want you to make a diagram FBD for it. Okay, the question is this: a body covers half of a distance with speed 2 meters per second and half of the remaining with speed 3 meters per second and remaining with speed 4 meters per second. Find the average speed. Now when I said the last part of the question, most of you might have stopped your pen and say, what, why, you have already given us 2 half parts, where is the third part coming from? See, listen to me again. A body covers half of a distance with speed 2 meters per second. So let us say this is the total distance which it has to cover. So the body is covering half of the distance with speed 2 meters per second, right? And then I said half of the remaining, that means what is the remaining part? This much is the remaining. So half of the remaining with speed 3 meters per second and the remaining with 4 meters per second. Find the average speed. This is the question. So from A to B, now again we can follow the same method, that is take the total distance something, I can take it as x. See, if I'll take it as x, the issue would be half of the distance would be x upon 2, remaining would be what? Remaining obviously would be x upon 2 only. So half of the remaining would become x upon 4. So if you are good in maths and you don't have complicated problems like how to take LCM, how to take denominator to numerator, because I come across many +1 or +2 students who are actually weak in this part, so I suggest them to follow that technique which is easier for them. For example, I can resolve this whole part into simpler thing like this. I can take the whole distance to be 4x. Now half of the distance becomes 2x and half of the remaining becomes x and x, so 4x. So the question, the way we will be solving it, total distance covered upon total time taken. So total distance is 4x, total time taken is t1 for this part, t2 and t3. t1 would be distance upon speed. Speed is here 2 meters per second. The distance t2 is x, speed is 3 meters per second. Lastly, the distance is x with speed 4 meters per second. You take out x common, it will get cancelled with this x. You will be left with this thing, 4 upon 1 over 2 plus 1 upon 3 plus 1 upon 4. How do we do here? Is it right? Have I written it right? This is wrong. Now this is right, right? 2 upon 2, it gets cancelled out. Now, how do we solve it then? We always take what? The LCM part, which is the LCM of 4 and 3 is 12. So I'll be left with multiply with 12. There are two methods of doing it. How do we do is multiply by 12. Multiplying 12 here. So what do I get? 12 upon 3 is 4. Multiplying 12 here, 12 upon 4 is 3. Whole upon what? What we have done? We have multiplied 12 here. So can we do this? We just multiply 12. No, we can't do this, but we can do this. So into 12. This is the way. Okay. What you guys are supposed to, are used to do is you take the LCM here only. So you what you will be writing is like this, and then this 12 goes here, right? This is the first step, and that so it is right both ways. Okay. So you follow any method, so answer would be same. 12 into 4 is 48. 48 upon 16, 19. 48 upon 19 would be your answer. So this is how you do this question. Now let's do one more. Again, try to make the free body diagram. An object covers a distance in two equal time intervals with speed 3 and 4 meter per second. An object covers a distance in two equal time intervals with speed 3 and 4 meter per second respectively. What is the average speed? What did I just say? An object covers a distance in two equal time intervals. It did not cover this distance in two equal parts. An object covers a distance in two equal time intervals. So if time to cover this much part, okay, I should not be making this. I should be writing this t and t. So why I have taken this part longer and this part shorter is because I want you to understand the concept that when an object covers some distance in equal time intervals, that does not mean that it will be covering the same distance in both the parts, because the object is moving with different velocities. So when small will be the velocity, it will be covering what? More of the distance, less of the distance. Obviously less distance, but it will take more time. Similarly, when object is traveling fast, it will be covering more distance in less time. So the question was, when an object covers a distance in two equal time intervals with speed 3 and 4 meter per second. So let us say it covered this much part with speed 3 meter per second and this much part with speed 4 meter per second. Alright. We don't know what was the distance. We can take the whole distance to be x. We can, but we know for sure that time taken from here to here is t, and from here to here is also t. Okay. What is the formula for average speed? Total distance over total time. So total time we know for sure is t plus t, because two equal time intervals. So I'm not going to mess up with the time changing the variable here. T plus t suits best. And what will I do with the distance? Total distance is, what is the formula for distance? Speed is equal to distance upon time. That means distance is speed into time. So for this part, the distance is speed into time, that is 3 into t, that is 3t. And for this part, it will become 4 into t, that is 4t. So it becomes 3t plus 4t. So 7t over 2t, that is 3.5 meter per second. Simple it was. So this is how you do average speed questions. So I have actually given you all different type of questions in average speed which might can be available in your books, different types. So we'll move on to relative speed now.